it's Mrs. Atkinson. Welcome. Today is Tuesday, April 14th. I hope you enjoyed yesterday's lesson on adding fractions with denominators of 10 and 100. Today, we're going to be using our topic 12 notes, just as we have been, to do lesson 12.5, which involves money word problems, a topic that everyone loves. All right. Decimals and money is actually one of my favorite things to teach because, like everyone, we all like money, right? All right, so if you haven't already taken it out, please take out your Topic 12 notes packet. We are going to be working today on a page that looks like this. It is lesson 12.5, solving word problems involving money. And we're going to use fractions or decimals to solve these problems involving money. It should say word, not world in these problems. Sorry for that mistake. All right, so let's take a look at an example and we're going to jump right in. Today's video isn't going to be quite as long as yesterday's. We're going to get right to work. Caitlin buys a toy airplane for $3.32 and a toy car for $1.12. So the question is asking, how much does Caitlin spend? Now, we know just from doing word problems and knowing all of the operations that this sounds like an addition problem where we're adding these $2 amounts to find a total. But we can not only solve this using decimal place value, we can also solve it a few other ways. And I want to draw your attention to that. So the first way we can solve this problem is actually by writing it as a fraction. So let's try that. I'm going to just circle my two amounts here so they stand out for us. So we can say $3.32, and we can write that as a fraction as 3 and 32 hundredths plus, now we're going to write this one as a fraction, 1 and 12 hundredths. And we know that when adding fractions, we're going to add our wholes first. So we're going to add the 3 plus the 1, which would give us 4. And now we're going to add our numerators. So 32 plus 12, right? That would give us 44. And we're going to keep our denominator of 100. So we get 4 and 44 hundredths, which is equivalent, if we were going to change this now back into a decimal, be 4 and 44 hundredths, which would be $4.44. All right, so we tried it as a fraction. Let's try it another way. Let's try to actually draw it out. So here's what this would look like. If I was drawing this out, I could draw out $3.32. So I'm going to make like these, that's going to be my dollar. So that's $1, $2, $3, and then the 3 is in the tenths place, so that would be like 3 dimes. So I'm going to make a circle with a D, a circle with a D in it, and another circle with a D in it. That would be 30. And then 2 hundredths would be represented by pennies. So I'm going to actually switch my color there. So a P and another circle with a P in it. So I have $3.32. And I'm going to be adding this amount to $1.12. So I have $1.12 would be 1 dime and 2 pennies. And if I was going to add that all up, I'm going to count my dollars first. So I have 1, 2, 3, 4. So I have $4. And let's count my dimes, 10, 20, 30, 40. And how many pennies? 1, 2, 3, 4. So it checks out. $4.44, $4.44. Now the final way that I'm going to show you to solve this problem is by using decimal place value and simply using the standard algorithm to add up our two amounts. Now, the one important thing that you must remember when adding money or adding decimals in general is that you need to line up your decimal point. line up your decimal point. It's so important. In fact, you need to line up all of the place values. But if you make sure that decimal point is lined up, you are not going to make any mistakes. So I have $3.32 plus $1.12, and I really want to just make sure. Sometimes I take my pencil and I just like go like that. I just want to really make sure that those decimals are lined up. And now I can add. And now it's adding just like normal. We're going to start in the column or the place value all the way to the right. And we're going to add 2 plus 2 would be 4. 3 plus 1 would be 4. This is the most critical step. We want to take that decimal point and just go all the way down with it and make sure it's nicely lined up. And now we're going to add in our ones column. 3 plus 1 is 4. We're going to label it with our $sign. And look at that, it checks out again. All right, so we solved that same problem 3 different ways. We used fractions, we used a model using the money, and we used the standard algorithm. All right, here's another variation of the problem, but now our operation is going to change. It says, how much more does the toy airplane cost than the toy car? So whenever you see these keywords here, it typically indicates subtraction. So let's try it that way. Let's do it, let's do it first as fractions, all right? So I want to take the toy airplane and I want to subtract that amount from the toy car. So I am going to say 3 32 minus 1 12 hundredths. And what's nice is that this really works out pretty nicely. I can do 3 minus 1. That would give me a whole number 2. And it works out here because I have that common denominator. I can now just subtract my numerators. 32 minus 12, which brings me 20. And I keep my same denominator of 100. So 2 20 hundredths would then equal 2 20 hundredths, or $2.20. So here's my final answer using fractions. I can also do this using the standard algorithm, and that would look like this. I would have $3.32 minus $1.12. And the most important thing is making sure those decimal points are nicely lined up. 2 minus 2 is 0. 3 minus 1 is 2. Bring that decimal point down. I can't tell you enough how important that is for those decimals to be nicely lined up. And then 3 minus 1 is a 2 again. And I could have also solved that using a model. I could have drawn out all of my $signs and then taken away all of my dollar bills and then taken away my $1 and 12 cents, and I would have been left with $2.20 as well. So key point here, and I'm going to write it with a star, you must, and please write this on your paper, line up the decimal points. And by doing that, you're lining up all of your other place value digits as well. Key. Very important. All right, let's do this other example problem. We're saying find $6.33, divide it by 3. And it's saying to draw bills and coins to model $6.33 and divide the bills and the coins into how many equal groups? Well, we have 3 equal groups here, so a 3 fits in there. Now, division of decimals is not a 4th grade standard. It's actually something you're going to be doing in 5th grade. So instead of using the standard algorithm to divide here, did I say 6th grade? I meant 5th grade if I did. We are actually going to model it using bills and coins. So our first step that we're going to do is that we need to draw it all out. So if I had $6.33, it would look like this. So it'd be like $1, $2, $3, $4, $5, and $6. All right, and now I have 33 cents, right? So I'm going to have 3 dimes. So a circle with a D in it, a circle with a D in it, a circle with a D in it. That's 30 cents. And then I have some pennies, 3 pennies. So I have to have a circle with a P, another circle with a P, and another circle with a P. All right. And now I'm going to distribute these dollar bills and coins to these 3 equal groups. So, kind of like Oprah and her favorite things, right? You get $1 and goodbye to that dollar. You get $1. You get $1. Don't forget to cross that out. Okay, I have another one. I can give you one more. And this group gets another one. And this group can get another one. All right, and you get a dime. You get a dime. You get a dime. And now I gotta do my pennies. You get a penny. You get a penny. And you get a penny. All right. So now I can simply add up what one of the groups is value is and get my answer. So I have $2, right? And 1 dime and 1 penny. So it would be $2.11, and that would be my final answer, right? Okay. And to just check that, I could use repeated addition because I haven't learned yet how to multiply decimals. So I could do $2.11 plus $2.11 plus $2.11. And this should get me $6.33. And let's see if that actually works. And yes, it does. So I know I'm correct. All right, awesome job, guys. All right, so this would be the part where you would now try on your own. So what I would like for you to do is pause the video to read through these 2 problems, try to solve them using any method that you would like. You can use fractions, or you can just try it with the standard algorithm. You could also try drawing it out if you would like to do that as well. But any method you would like, and then fast forward the video to see if you got the right answer. All right, here's the example. A new pair of Nike shoes are on sale for $64.21. And a new pair of Nike sweatpants are on sale for $22.68. If Charles buys both, how much does he spend? Solve any way we choose. So I'm thinking the operation is going to be addition because I want to know how much Charles spends in total. So one way that I could do this is I could use fractions. I could say 64 and 21/100 plus 22 and 68/100. And if I was going to do that, I'm just going to say T for my total. Let's use a variable in there. And I would get 86 and 89/100, which would then equal $86.89. Make sure that decimal's in there nice and clear. All right. Another way that I could solve that same problem, and this is probably the way that most of you chose to solve it, is to use the standard algorithm. So 64.21 plus $22.68, making sure those decimal points are nicely lined up. 8 plus 1 is 9, 6, 7, 8. Bring down that decimal point. And we also get 86.89, 86.89, and we are good to go. For our second example, we have Mr. Long found $12.66 in the hallway. That's very fortunate of him. He decided to split it with Ryan and Lavinia. They're very lucky. And I guess he gets to keep some of it himself also. How much does each person get if the money is split into 3 equal groups? So Mr. Long will get some, Ryan will get some, and Lavinia will get some. And so I can think about this, right? I have Mr. Long, I have Ryan, and I have Lavinia. So I can kind of use a little bit of division in my thought process here. If I have $12.66 and I'm dividing it by 3, well, if we forget about the 66 cents for a second, we know that 3 times 4 equals 12, right? So 12 divided by 3 would be 4. So technically, I could give them each $4. Okay, and now let's consider the change portion, right? The decimal portion, 66 hundredths, right? I also could take my 3, right, and say to myself, well, 3 times what equals 6? That would be 2, right? So 2 tenths here, 2 tenths here, and 2 tenths for Lavinia as well. And same thing with my 6. My 6 hundredths, right? So 6 divided by 3 would be 2 again. So I could do 2 hundredths here, 2 hundredths here, and 2 hundredths here, giving me $4.22 per person. Just to check this, make sure that I'm correct, I could use that standard algorithm to add everything up. $4.22 plus $4.22 plus $4.22. I could also multiply. If you knew how to do that, you could do 422 times 3. And 246, 246, 4 times 3 is 12. And so I get 1266 here, and that is my answer. All right, so I know that I am correct. You could also draw out a model for this. Okay, you could have drawn out $12.66, right? So it would be $12 bills, it would be 6 dimes, and there would be 6 pennies, and then I could distribute them, right, to each person equally. All right, guys. So today's lesson was all about solving word problems involving money. The big takeaway that you need to remember is that you must line up your decimal points. Most of you will be solving all of our problems using the standard algorithm, but I did want to show you how it works with modeling as well as with fractions in case those strategies work better for you. This is the key idea though. Making sure those decimal points are lined up is what needs to happen. And if, let's say you had a decimal like 3 3/10, what you could do is add in a 0 just to hold that place value position. So that's like a really important thing also. Actually, let me just show you that. Let's say I had 5 3/10 minus 2 and I don't know, let's say 17 hundredths, right? And so this is written horizontally. The first thing you want to do is rewrite it vertically. So let's do that and let's line up our decimal points. We are subtracting. We want to make sure those decimal points are super duper lined up. So that's what it would look like. But wait, I can say most of us, our first instinct would just be to put a 7 down here, but that would not be correct. What we need to do is fill this place value spot with a 0. I like to just make it all nice and even. So we have twins for each of our place value positions. So now 0 minus 7, can I do it? No, I need to go to my friendly neighbor. I am going to take it away from him. This becomes a 10. I have 10 minus 7. 7, 8, 9, 10 would be a 3. 2 minus 1 would be a 1. I bring down that decimal point, so important. And then 5 minus 2 would be 3. And then your new answer would be 3 13 hundredths. Notice that I'm not dealing with money here, but I could have been if I wanted to. In my original position of my original problem, if I was dealing with money, instead of saying 5 3/10, this probably would have said 5 30 hundredths. And now we know that 3/10 and 30 hundredths are equivalent. All right, guys, thanks so much for joining me today. Hope you can make it for our live Zoom lesson at 9 a.m. And please feel free to bring your questions to me anytime you have them. Have a great day.